Good Sunday morning. Going to preach about tomography. Tomography. I put a little info down below in the description about the word, the concept, what it means. But back in the good old days, when we had pencil and paper, and that was it. That was it. Well, we made a slide rule. Slide rules helped a lot, and still do for some folks. But we started drawing cross sections of things, right? You've seen that, a cross section of the Earth, with the core of the Earth and the layers and the crust and then space outside the Earth. And then it might go further, add a moon out there. But that cross section idea, that is a type of tomography. Only it was done purely with intellect, not with computers. The intellect, a person getting information about how the planet's built, right? And being able to present it. So they presented that in a piece of paper, two-dimensional thing, right? But it's a three-dimensional object. So it's a cross-section of a three-dimensional object. So in one way, it's very simple. It's just being able to create a cross-section view of something. And that could be called tomography. But then you get into very specific sciences and how it's applied and used. And you bring a computer into this. So before the human got data from somewhere, they might have gotten it from an instrument or from a reading. They might have taken lengthy measurements over weeks and months and written these things down and developed this picture from numbers, this two-dimensional presentation or three-dimensional presentation, because in his mind and on his paper he can take and rotate that structure again and change that angle and redraw what the inside of it looks like. That is a form of tomography. You're trying to envision what's inside another object. So when computers came along, computers gave us the ability to do this analysis in near real time. Instead of taking weeks or months and analyzing data that might have been collected over years or decades or generations, or since nature began building history for us, right? So this is how we see into the crust of the earth. This is how we see into what's inside planets. This is how we see what's inside your body. CAT scan, computer-aided tomography, PET scan, positron, is that positron? Emission tomography. What the types of scans are there that might be familiar with PET scan, CAT scan, there's another one, magnetic resonance imaging, MRIs. It's actually nuclear magnetic resonance imaging because your body is injected with some materials that tend to bioaccumulate in certain areas of your body with enough concentration that the sensitive detectors inside the rotating head of the MRI machine can detect. And through thousands and millions of detections and angles and inferences and power level measurements, the computer sits there and gathers this data and gives it back to itself to process, to assign colors to be able to put it onto a screen for a technician or even for you to be able to go look and see the shape of your mind and maybe how pieces of it work, one view of it works. That's tomography. This is an amazing concept and word. Now, to use it, you're looking inside of something with data, with information. You cannot see inside the crust of the earth unless you dig, or unless you do, what would that be called? Seismic measurements. Or you take a hammer, an explosion, you slam the earth itself, and you have sensitive microphones that exactly time and listen to the reflections of that hammer, the reflections through the ground of that hammer, and then through massive amounts of data processing. It's presented to you as a cross-section of the earth below. You get to see the layers and the structures. That's tomography. It's a form of huge data analysis. It has to have trusted data. So this field, this science, gets very specific depending on what types of energy. CERN is performing a type of tomography, a type of time-sensitive mapping, very fast. The reason we can do this is because we've invented, created, have the ability to measure super fine, super fast, very quickly. CERN creates petabytes of information to make a few pictures for students, professors, and collegiates, and other people in the newspaper to share with. Petabytes, you can't imagine that. Petabytes of trusted information in order to build whatever CERN's trying to build, a knowledge base, an understanding of particle physics, to move it from theoretical particle physics into usable particle physics. So the moral of the story is we don't need to boil water to make energy, to make electricity. We really don't. Tomography, should I do more on this better? Yes, maybe, who cares?